Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Today, inshallah, we will start chapter number 8, the normal distribution. We already completed with you chapter 7, which deals with the discrete probability distribution, which are the binomial and geometric. Okay, today, inshallah, we will start. I will give you introduction about the normal distribution. The normal distribution. Okay, let's start with the random variable. As you know, the random variable here, there are two types of random variable. Discrete, as we said before, and continuous. Okay, what is the discrete random variable? Do you still remember? Hopefully, yes. Yes, it is the discrete random variable. It is any variable which can be expressed by countable numbers, by whole numbers. Yani it may take here the random variable values 0, 1, 2, 3, 4, 5, and so on. Yes. While the continuous random variable, can be expressed within a range of values or in interval. In other words, we can use the real numbers really to express the random variable. Yeah. So we can say it is a variable which can be expressed in a range of values or in interval, within interval. I will give you an example. يعني, let's come to speak about the mass of apples. Mass of apple. If you have a packet contains, let's say, 30 apples. 30 apples. Now imagine with me. Now if we bring a scale, okay, and we want to weigh the mass of each apple. What will be the mass? Maybe you have 152.5 grams, maybe 151.32 grams, and so on. 100, let's say 49.42, and so on. So the masses of the apples, if we are dealing with the exact value, we are going to deal, look here, they are not whole numbers. They are real numbers. Now imagine with me, if I want to select one apple randomly, can I raise that question? Or yes, look here. If I want to raise that question, what is the probability that the selected apple, its mass is 150 grams? 150 grams. Or let's say 152 grams. What's the probability? If you want to select just one apple randomly from that packet, okay? So what's the probability that the selected apple is 152 grams? Maybe here it is impractical to deal with that type of questions in this case, in the case of continuous. Why? Because maybe you cannot find 152, you can find 152.5. Is it clear? So the probability almost will be zero. Yani, if I want now to select, what's the probability that the selected apple, its mass is 149.3 grams? Maybe you cannot find. Maybe you can find 0.4. You can find 0.7. Maybe you can find 149. But specifically 149.3, no. So the probability in this case will be zero. The probability always, if we are dealing now with individual value, what's the probability that the selected apple, what has a given value, one value only, 152. In that case of continuous random variable, like mass is a continuous random variable, the probability here in this case for a given value, one value will be zero almost. يعني, imagine now here the height of the students in your class, okay? يعني, even the height is another example for continuous random variable because we are expressing that variable using real numbers. What is the height? A certain student 170.3 centimeter. Other students 168.5, and so on. طيب, if I said I want to select one student, what's the probability that the selected student here will be 100, let's say, 67.7 centimeter? Here in this case, I can say 0. طيب, in such situation of continuous random variable, how to deal with the probability? In this case, better to deal with the intervals. Better to deal with intervals. In this case, you can count the favorable outcomes. I will give you an example. يعني here, about the apples. If I told you now, what is the probability that the mass of the apple between 150 gram, let's say, and 155 grams? I think here, if we say that the mass between 150 and 155 grams, I think in this case, you can count the favorable outcomes. And the values here that you are interested in will be countable. You can count them. You can identify them. So here, I can easily apply the rule of probability, the major rule, which is the number of favorable outcomes over the total number of outcomes. So if I have a packet, let's say, of 30 apples, okay, 30 apples, I'm weighing each apple, yes, is it within that interval or not? If it is, so it is one of the favorable outcomes. So you will count it. Okay, the first one, yes. The second one, yes. The third one, no, and so on. So easily in this case, in the case of continuous random variable, you cannot deal in the case of individual value to say, what's the probability that the mass of the apple is 150.47? Imagine here. طبعا here the probability is 0. يعني impossible almost to deal with in this case, okay, to find the favorable outcomes. Very rarely يعني. So almost the probability will be 0. But in the case of interval with the continuous random variable, yes, we can deal. That's why the continuous random variable, we can use the real numbers to express these variables, okay? And it will be always used within interval. It will be used within interval. This is the continuous random variable. While the discrete, it is countable. Its values are countable, okay? That's why here, their values are separate. 0, 1, 2, 3, they are separate. But here, they are not separate. يعني 2.0001 maybe, 2.003, okay? So it is within interval. So the continuous random variable, we are dealing with that within interval. So if we have continuous random variable in the random experiment, like mass, like height, like the time needed to complete a marathon, or a certain race, for example, number of, let's say, electrons or protons in a certain mass, okay, and so on. So if we are dealing with the continuous random variables, we will be able to find the probability for that experiment random, which deal with the continuous random variable within interval. We will calculate the probability within interval, not what as individual value like this case, because the probability will be 0. تمام. Okay, let's move now to the next point. Let's move now to the next point. طيب, if we are dealing now with the interval, if we have a certain random experiment, statistical experiment, okay, and we want to find the probability distribution. We want to find the probability distribution. Do you still remember when I told you that the probability distribution, either what? Say, it is either a table or bar chart or equation, right? Do you still remember that? طيب, in the case مثلا, in your class, I have 17 students and I want to measure the height of the students, okay? And we want to deal with the probability distribution of the height of the students, okay? So we will say, okay, we found that the highest height, let's say 182. MashaAllah, Arya is the highest student here. He or maybe Nuruddin, one of them. Okay? Okay? Let's say, suppose the highest is 180. And the least is 165, suppose. And we want to break them into intervals. 100, let's say 70. Then here, as you know, that meaning before 170. So starting from 165, this is the least, let's say. Okay, let's say that the least height in your class is 165.2. So I can start easily with 165 to 170, to less than 170, of course. And here from 170 to 175. And here 170 to 180. Then here to 185. Okay? These are the intervals. Okay? Now here I can count the number of students who are located in that interval. Right? So we will count from your heights, okay? We will count what's your height according to the measurement. Okay, your height so and so. So we will count, let's say, I have here 3, I have here 4, I have here 5, I have 7, suppose. And here I have 1 or 2, مثلا. Say here 6 here. And so on, 3, 4, 5, 6, 2. Okay? طبعا here 175 and here 180. Okay? تمام. So here in this case, I can find the probability. يعني if we want now to select a student, what is the probability that the height of the student is 165 between and 170? It means here in that class interval. So easily you can calculate. It is 3 over the total here 7, 12, 18, 20. Let's say 20. Okay? 3 over 20. This is the probability. Look, with an interval, it is easy to deal with, to find the probability because it is continuous random variable. Okay? So it is 3 over 20. So this table now shows here the probability distribution, right? طيب, can I use the histogram to represent that case? Yes, I can. Of course I can. So, and we studied together how to represent, how to use the histogram. Okay? طبعا the histogram you need to make the frequency density and all of these things, as you know. But I will jump over these and I will draw approximate histogram. Let's say if the histogram is like that. As you see here, the class interval, the width of the class interval is equal from class to other. Suppose, okay? Suppose it is like this. This is the histogram. Okay? Now we will come to make the connections with the normal distribution. Then, first of all, we started with the random variable, and we said that there are 2 types of random variables, discrete and continuous. Continuous, what is that? We can use the real number to express that variable, or it can be taken within interval. This is the random variable. Okay? That's why always in the continuous random variable we are dealing with measurement of height, measurements of math, measurement of time. Okay? All of these things. ولذلك يعني there are many definitions for the continuous random variable. You can find the continuous random variable. One of it is the variable which is found by measurements, the continuous random, or it uses the real numbers to express the outcomes, okay? While the discrete use the countable or whole numbers only. Okay. طيب, this is the histogram, suppose the histogram of that continuous random variable experiment, okay? Now here in this histogram, Sometimes you have a histogram in experiment like this. As you see here, here in that histogram, you find that it is almost like symmetrical. Symmetrical. Almost it is symmetrical. Other histograms, they are constructed sometimes like this. This is not symmetrical, right? Other histogram in different questions, it depends. Sometimes you can find it in that way. So we have different histograms for different statistical experiments. It depends upon the question that we have. It depends upon the table that we have. So from question to other, the histogram will be drawn accordingly, according to the data that you have. Is that clear at this point? طيب. We found that if we connect here by a curve, I will speak about the function of that curve. Okay? That type of the curve, almost it is called normal distribution curve. Normal distribution curve. It is what? Normal distribution curve. What is the normal distribution curve? If I want to draw it here, I'm jumping over many points which are not required from you, as a matter of fact. Okay. This is the normal distribution curve. It is bell-shaped curve. Bell-shaped curve. And that curve, by the way, follows an important function or equation. This equation is, I can write it here for you. So this is curve, right? So it follows that equation. This equation is not required, just for your knowledge and information. This is the normal distribution. Really, this normal distribution is bell-shaped, like bell. Here, where it is symmetrical around the mean, this is the mean. And where mean, mode, and median are equal. So the normal distribution is a bell, you will say it is a bell-shaped curve. Follows that equation, which connect each random variable with its probability. By the way, the f of x will calculate for you here. It will connect between the x and the image of x to sketch that curve. Okay? And that curve always is symmetrical around the mean. And where the mean and mode and median, they are equal. So any bell-shaped curve, okay, is called normal distribution curve. يعني any statistical experiment, if you want to draw a histogram for it, and you will find that the bars almost from the right and left, they are same almost, okay? We can say that this experiment almost is normally distributed. Normally distributed. We have different normal curves. Maybe here the mean, the value of the mean is 10, okay? We have another statistical experiment, like dealing with the mass of apples here, مثلا dealing with the height of the students here, mass of apples in a certain bucket, maybe you will find like this. Okay, with the mean, let's say, مثلا, suppose, with a mean 15. Okay, this is another normally distribution curve, normal distribution curve. But here in this case, what's happening? Since it is compressed, what's the meaning of that? It means sigma. Here, which one is? Do you think that sigma here is more or here? طبعا here, if I said sigma 1 and this is sigma 2, here we can say that sigma 1 is more than sigma 2. Why? Because here in this case it is compressed. It means the values are very close from each other. As you know that the sigma here, standard deviation, it means the standard deviation or S, no problem. Okay? So as you know, it is the measurement of dispersion. Okay? So more sigma you have, it means the values are very far from each other, more, and they are very far from the mean. While you have sigma less, variance less, standard deviation less, it means that it is compressed. So here the sigma here is more than here. But what about the median or the mean? Here the mean is 15, while here the mean is 10. So we have different shapes of normal distribution. Sometimes it is compressed, but it is normal distribution with less sigma, and sometimes what? More than. Yani sometimes we can draw even the normal distribution for a certain like this. This is normal distribution since it is symmetrical around the mean. Since it is symmetrical around the mean, this is normal distribution. But what do you think about sigma here? The sigma, yeah, it is the biggest, more than in this case and here, that case, okay? But if you say in the number line, if you extend that one, maybe here it says 150, but the mean here is more. So here, the normal distribution curve, it is a bell-shaped curve determined, by the way, by two parameters, by a mean and the variance, we will say. So always the normal distribution, if any random variable follows normal distribution, always here we have two parameters which determine that curve. It is the mean, we call it mean, mu, x bar or mu here. The mu, we will call it mu, x bar here, and the variance. There are two parameters for the normal distribution, always the mean or the variance. Here the mean 150, while here 10, here 15, in different random experiments. Okay, here the sigma, in this case, okay, is more than this, but that one has more sigma than others. Here also we have the highest mean, okay, the biggest value of mean compared with others, compared with other models. Okay, so this is the issue, this is the beginning of, or I can say, a simple introduction about normal distribution, and inshallah in the coming videos I will come to attack how to find the probability using the normal distribution. And this is our issue, how to find the probability if a certain experiment follows normal distribution, deals with the continuous random variable, and it is normally distributed. Once I said normally distributed, it means here in that experiment, if we draw the bar chart, if we connect the lines between them, we can get almost a curve like bell-shaped, and that curve is symmetrical around the mean. Symmetrical around the mean. From the mean and goes to both sides asymptotically. Yani it means it has tails, similar tails plays once it's moved toward the x-axis. Okay? So this is the normal distribution curve. It is a bell-shaped, again, bell-shaped curve, okay? Where that curve is symmetrical around the mean. And always the mean and median and mode in the normal distribution, they are equal. Always the mean, mode, and median are equal, always. This is one of the major characteristic of the normal distribution. Any continuous random variable which follows normal distribution, okay, always has two parameters, the mean and the variance. Inshallah, in coming videos, we will come to attack the major points that we have in the syllabus. This is just general knowledge for you, okay? But we will come, inshallah, in the coming videos to speak about how to calculate the probabilities using the normal distribution. Shukran jazilan. Thanks a lot for you. My best wishes. Assalamu alaikum wa rahmatullahi wa barakatuh.